In this video, we're going to look at mutable variables. These are variables that can change their value after they're defined. In many programming courses, mutable variables are the first thing you learn about. But we've waited this long to introduce them for three reasons. Even though mutable variables are fundamental in many languages, they're actually surprisingly complex. Overusing mutable variables can make programs difficult to understand, and overusing mutable variables can lead to programs that are difficult to run on parallel or multi-core hardware. And since multi-core hardware is becoming prevalent, it's another reason to wait to use mutable variables. The style that we want to impart in this course is something called mostly functional programming, where we use mutation when it's necessary and when it helps, but we avoid using mutation, or we use a functional style the rest of the time. That approach is going to lead to programs that are easier to understand, not just in languages like the teaching languages or the underlying racket language, but also in languages like Java. The first thing we've got to do is select the advanced student language. That's the language we're going to be using to do mutable variables. And there's going to be a couple differences between ASL and the previous languages. There's going to be a couple new expressions. The behavior of define is going to change slightly, and we'll see that functions can now have 0 parameters. Let's start with define. We're going to say, for example, if we take a define like this, now we've seen that lots of times before, and we know what that's meant in the past. It's meant that you evaluate plus 2, 3 to get 5, and from that moment on, x is synonymous with 5. But now it's going to work slightly differently. What we're going to do is we're going to evaluate 2 plus 3 to get 5. And then there's going to be a box, and I'll just use a racket box to show this. There's going to be a box associated with that x, and we're going to put the 5 in that box. And what does that mean? Well, it means that if I then just write an ordinary expression, for example, plus x3, and I run this program, well, I get exactly what you would think I'd get. X is 5 and x plus 3 is 8. But we're going to describe the difference slightly differently. What we're going to do is we're going to say that our rules of lexical scoping that we've learned before are going to tell us how to get from x to the box that it names. And whenever we have a variable reference like this, we'll first find the box that x names, and then we'll take the value out of that box. And you'll see in a minute why we're doing it that way. Here's the first new expression. It's called setBang. And setBang takes a variable name there, and then it takes an expression. Like, let's just say, as an expression, we'll say times 3, 4. Now, how does setBang evaluate? Well, the first thing it does is it evaluates the expression if it's not already a value. So in this case, the next step is that. And then is when the interesting step happens. What setBang does is it uses the normal rules of lexicoscoping to find the box that x names. So in this case, x names this box here. And it goes to that box and changes the value in the box to 12. setBang produces void when it evaluates. And void is a funny value that you can't really do anything with. It's a value that has no value in some sense. setBang just produces a value because it must produce a value. It's an expression, but it's not producing a value that you can use. So let's run that now. And of course, running it didn't change my animation. I'll just hand step it quickly for you. We start with define x plus 2, 3. So there's a box called x with a 5 in it. This, of course, produced 8. And then setBang x to 12 goes to the box and changes it to 12. And if we really want to see what's happening with mutable variables, let's add one more expression to our file here. Let's now say plus x3 again and run that. And now something very interesting has happened, which never happened earlier in the course. We have two expressions which are identical, and they produce a different value. because at the time that this expression is evaluated, x is 5. X starts out as 5. Then the set bang changes x to 12. And then at the time this expression is evaluated, x is 12. And so its result is 15. That's the most useful and also the most complicating property of mutable variables, which is they lead to expressions like this, which at different points in time produce different results. That's useful, as I said. It can also be confusing when you're debugging and you're calling a function, for example, and it produces a result that isn't the result it produced during the program. If you make indiscriminate use of mutable variables, it's hard to see what's going on. And we're going to talk instead about how to make appropriate use of mutable variables. Okay, let me show you another expression called begin. And begin works like this: open paren begin, and then any number of expressions you want. Now, how does begin evaluate? Well, the first thing it does is it takes the first expression in the begin, and it works on that. So that begin, the next step of the evaluation is going to be begin 3 plus 1, 2 is 3, and then times 4, 3. And then begin does an interesting thing, which is it throws away the result of evaluating its first expression. If there is more than one, it throws away the result of evaluating the first one. So now this becomes times 4, 3. That then evaluates to 12. And now that 12 is a value, and it's the last expression in the begin. So that's what begin produces. So said more succinctly, the rule for begin is that begin evaluates every single one of the expressions in its body, and it produces the result of the very last one. So that begs a question. If begin is going to throw away the result of every expression except the last one, why on earth would you ever use it? Well, you're going to use it with setBang. Well, you might use it this way. Let's define another variable c that starts out as 0. So again, in ASL, that means there's going to be a box, and when this program runs, the first value in that box is going to be a 0. And here's an expression. We'll say begin setBang c plus c1 and then c. So what's that going to do? Let me comment out all the rest of this. And I'll first just run it. Let me just run it, and I'll erase what's in this box so we don't think that Racket's updating that for us. I'll just run it, and we'll see that that produces 1. Now the question is, why did that happen? Okay, let's walk through it. So we say define c as 0. That makes a box called c and puts a 0 in it. Now we have a begin. Begin evaluates the first expression. Plus c1 is, well, c is 0, so plus c1 is 1. And now we're going to set bang c to 1. Now begin evaluates its second expression, second and last expression. Let's see, it gets the value of c. Well, the value of c is now 1. So now you see what begin is for. Begin is useful when we're going to change some mutable variable, and then we want to produce a result that involves that mutable variable. Okay? First we do the changing, then we produce the result. And the reason begin takes multiple expressions rather than just 2 is sometimes you might want to do several mutation operations before producing a result. Let me show you a classic example of how this is useful. I'll comment this out now, and I'll get rid of the box so that we don't think that Racket's going to keep displaying that box for us. Here's a simple function called next. And what it does is it says begin setBang c. It does exactly what we have above, plus c1, c. Let me put a call to next in here. I'll put a couple calls to next. Next, next. And I'll run it. And what we're seeing is the first call to next produces 1. The second call to next produces 2. The third call to next produces 3. And down here, if I say next, I'll get 4, and so on and so on. You may have wondered when I first wrote next, gee, this function has no parameters. How can a function with no parameters work? Well, what's happening in this case is that next is getting its changing value to operate on from the mutable variable c. And so here we have a meaningful function, next, that produces the next value each time. We've never seen a function before that didn't take any parameters, because if in the past, if we had a function that didn't take any parameters, it would have to produce the same result every time. It wouldn't make any sense. But now that we have mutable variables, if we have a function that uses a mutable variable in its body, we can make a function of no arguments that changes its value every time. It doesn't mean that every function that uses mutable variables is going to take no arguments. This is just a very simple example. So there we go. That's define, the new rules for define, in which define now makes a box, sets up this value in it, a new construct called setBang, which keeps changing the value in the appropriate box, and begin, which allows you to have a single expression which both does some mutation and then produces a useful value. And also this detail that functions can take 0 parameters. When we get to lecture, we'll look at how to use this mechanism and design with it systematically.